This is our second example of graphing from intercept form. So in this particular example, we don't have the actual two binomials that you see in your intercept form. Reminder, intercept form is f of x equals a times x minus p, x minus q. So the question on this one is, we have x instead of something that looks like this format, x minus p. So we know one of our intercepts is going to be positive 6. We know that q is going to be 6 because this factor is x minus 6, and that is our x minus q. So that is going to be 6, 0. That's going to be our first intercept. But what about this x value right here? What do we do with this if there is not a constant after that value? So actually what this equals, it would be the same as if we wrote x minus 0. So when x is by itself, that would be the same thing as writing the equation, but instead of x, having x minus 0. So now this creates a better picture for us. So we know now that our p-value is actually, in fact, 0. That's because there is no constant value attached to this particular factor. So 0, 0 is going to be our other x-intercept, or our root. So I'm going to go onto my graph, and I'm going to put a point at 6, 0, which is my first intercept, 6, 0. And I'm going to put a point at 0, 0, which is my other intercept. So now I have my two x-intercepts. After you find the x-intercept, remember the next thing you're going to do is you're going to find the axis of symmetry. So I'm going to find the axis of symmetry for my value. I'm going to find the axis of symmetry using my p-value and my q-value because I know the axis of symmetry runs exactly halfway between my two roots. In this case, my axis of symmetry, which is the formula p plus q divided by 2, is going to yield p, which is 0, plus q, which is 6 divided by 2, and that gives us 3. So my axis of symmetry is actually going to be a vertical line at x equals 3. So that is my axis of symmetry. That is the line that divides my parabola into two equal halves. It runs right through the center. And remember from our previous example, we also know that the axis of symmetry contains the vertex. So I'm now going to find the coordinates of the vertex. Well, I know the vertex lies on the axis of symmetry, so my vertex must have an x-coordinate of positive 3. So what I'm going to do to find the y-coordinate of my vertex is I'm going to use my original equation. So I have negative 1/2. I'm going to plug in 3 for x, 3 minus 6. And that will give me negative 1/2 times 3 minus 6, which is negative 3. So I have negative 3 times positive 3, which is negative 9. And negative 9 times negative 1/2, a negative times a negative equals a positive. And 9 divided by 2 gives me 4.5. So my vertex is going to be at the point 3, 4.5. So I'm going to go over to 3 and go up 1, 2, 3, 4.5, 4.5. And that is my vertex. I can see my parabola starting to take shape, and I notice that the parabola is going to open down. Not only because I see it on the graph, but I should have known that from the beginning because my a value is negative 1/2, which means since the a value is negative, my parabola will open downward and my vertex is going to be my maximum point, or the top. So now that I found the vertex, the last thing that I want to find is the y-intercept. And to find the y-intercept, remember when we found the x-intercept, the y value was 0. To find the y-intercept, we're looking for where the x value is 0. So I'm going to go back to my original equation up at the top, and I'm going to rewrite it, except in place of x, I'm going to put a 0. Now, when we multiply this out, we get 0 times -6 times -1/2. Well, any product that contains a 0, when you're multiplying, 0 times anything is 0. Therefore, it's going to be 0. So our y-intercept is going to be 0, 0. And what do you notice? We've already plotted our y-intercept. It just so happens in this particular example that the y-intercept is also one of our two x-intercepts. So now we're ready to actually construct the parabola. So down it goes. Again, it's opening downward because it has a negative a value. And there is your parabola. Not the best picture in the world, but that gives you the idea. So again, this example tells us what to do when there is no constant attached to our x value in our factor. That is when we assume that is an x minus 0, because we could write this as x minus 0, so you would write it in this format. -1/2, x minus 0, x minus 6. That enables us to identify our p-value, our first root, or intercept, x-intercept, as 0.